Welcome back to LearningStrome Academy. So friend, if you haven't pressed our bell icon, so please press it so you can directly get our videos more and more. So keep subscribe our channel, friend. So today the topic that we are going to discuss is friend bitwise operator. So friend, actually this is one of the most important operator used in Java actually, friend. So let's discuss about it. So actually friend, bitwise operators Active friend bitwise operator is which kind such kind of operator friend which deals with the individual bit of a number. Okay, so in Java friend we have four kind of bitwise operator. Okay, so first operator that we have friend in Java is bitwise AND when it is denoted by single ampersand sign. Okay, so friend actually bitwise AND operator is binary operator. Okay, it's denoted by so it's denoted by ampersand. If when binary operators mean that we are going to use always two operands for it. Okay, it returns one if and both bits is one. Okay, else it will give us zero. Okay, actually friend, it works on the individual bits of a number. That's why friend here we are talking about the bits. If it return one if both bit is one, else it will give us zero. Okay friend, let's see an example. We have two numbers 6 and 8. First of all friend, we need to convert this number in a binary number. Okay, so let's see the binary number for 6. It is friend 0100. Actually I'm using here 4 bits only. Okay, so our example remains simple. Okay, the second example, the binary number of 8 is friend 1000. Okay, and after performing the AND operation friend, as we know, it will return 1 if both bits are 1. Okay, otherwise it will return 0. So friend, see here, in no case there is a both bit is 1. Okay, see here 0 1 1 0 1 0 1 and 0 and 0. So friend, here we are going to get 0 as an output. Yeah, because friend, there is no two bits are same, or no two bits are set to 1. Okay, that's why we are getting output is 0 0 0 0, which whose decimal number corresponding to it is 0. Okay, so this is a bitwise AND operation. Okay friend, so friend, bitwise and the another operator we have is bitwise OR. Friend, actually bitwise OR, it is again another binary operator. Okay, it is denoted by a pipe symbol, single pipe symbol. Okay, it returns if either of the bit is 1, it give 1. Okay, else it gives 0. Okay, it's mean that friend, let's consider an example, so it will be clear to all. We have two numbers 6 and 8. Okay, so first we need to convert 6 again in a binary number. So binary number corresponding to it is 0 1 1 0, and the binary number corresponding to 8 is 1000. Okay friend, after friend operation performing OR operation, see friend, as I told you, if one of two bit is 1, the answer is 1. Okay, it will give you 1, otherwise 0. Okay, see friend, here from bit 0 and this 1. So as I told you, if one of the bit is 1, the answer will be 1. See, we are getting 1 here. If the one of bit is 1, we are getting 1. If one of the bit 1, we are getting 1. Okay, 0 and 0, we are getting 0. Okay, so friend, after converting this decimal number, binary number to decimal, we are getting 14 as an output. Okay friend, this is all about friend, the or bitwise OR. So let's talk about the bitwise XOR friend. Okay, since bitwise XOR operator again is a binary operator friend, it is denoted by XOR. It is denoted by friend the this symbol. Okay, so friend, it gives one if both the bits are different only. Okay, it gives one friend if both the bits are different. Okay, else it gives 0. Okay, it is actually friend, okay, if both the bits are one now, oh sorry, both the bits are different now friend, then only it give you 1, otherwise it will give you 0. Okay friend, actually friend, it is wrong here. It is wrong here actually. So now it is right friend, if both bits are different then it only give 1, otherwise if both the bits are same, okay, then the our output is 0. Okay, so if both bits are different then it gives 1, and if both bits are same then output is 0. Okay friend, so this is the working of the XOR operation friend. Okay, So let's we have another operator in bitwise operator, that is bitwise complement. Okay, friend. So bitwise complement, friend, is a unary operator. Okay, it's mean that we can all work this operator work with only one operand. Okay, it is denoted by tilde symbol. Okay, friend. It gives actually, friend, one's complement. Okay, one's complement representation of the input value. Okay, friend. So friend, this is about the bitwise bit operator. Okay, friend. So friend, actually let's take an example of bitwise complement. Friend, see, if I have number 0110, okay, and I want to apply the bitwise complement on this operator, friend, in this case, friend, the bits of the number will be changed. Okay, if the 0 will be converted to 1 and 1 will be converted to 0. Okay, see, friend, here 0 become 1 and 1 become 0, and the binary the decimal number corresponding to this number is 9. Okay, this is all about bitwise of complement. But friend, there is a few point that I would like to say you, friend. We can apply bitwise and or and XOR operator on the integral types and also on the boolean types. Okay, friend. But friend, bitwise complement operator we cannot apply it on the boolean types. Okay, so let's see an example where it will be clear to you all. Okay, so let's see an example, friend. See, friend, we have a bitwise number. Okay, let's, friend, if we have an integral number a and b, and I want to friend perform an AND operation among them. So then, friend, let's first we need to perform first we need to compile this program. So let's compile this program, friend. Bitwise dot java. Now, friend, let's run this program. Yeah, friend, see, we are getting 2 as an output. Okay, friend, because okay, at the AND operation among them. So friend, that thing that I want to tell you right now, that we can perform bitwise operation, bitwise AND operation with integral data and the boolean data. If I have a true, see, friend, if I have a, so let's see, if I want to play, let's see it, if it is work or not. Let's see, I have a boolean value, I have boolean value int. Okay, I want boolean value, I have boolean value a, and I have another boolean value b. Okay, and I want to perform an AND operation among them. Okay, friend. So see, what will be the answer? Let's say compile this program first, and let's run this program first. See, friend, we are getting true. Okay, so the thing that I have to tell you, friend, that we can apply boolean operator on integral data and also on the on sorry, we can what I am saying, yeah, we can apply bitwise AND operator on the boolean data and also, friend, on the integral data. We cannot apply it on the floating point data. Okay, friend. So and string and over on the other kind of data. Okay, friend. So keep it in mind. Okay, friend. So friend, one more thing that as in case yeah, so it is all about the boolean and. Okay, so friend, same with the boolean or operator. Okay, if I want to apply boolean or operator, bitwise operator. So friend, see, yeah, we are getting true. Okay, so one more thing that I I told you, friend. Yeah, so friend, one main difference among them bitwise and logical led, friend, and that in case of bitwise, friend, the both condition will be valued always. Okay, it is not going to evaluate only first condition or second condition is optional. But friend, in case of bitwise and or operator, both condition will be evaluated. Okay, friend. So it is all about that. So now it is clear to you all which kind of data is valid for the boolean data, bitwise and or operator. If I'm going to consider a float kind of data, friend, see, if I'm using float data, let's see, let's use a float data or any see, in this case, friend, we will get a compile time error, friend. See, let's save this program and let's compile this program. And then, friend, now you can see that we are getting compile time error, that the bad operator we cannot apply here it. Okay, so friend, now I think it is clear to you all that we cannot apply the only valid kind of data for the bitwise and or operator, and band and or operator is, friend, what And XOR operator is what, friend? Integral data and the boolean data. And friend, and the only valid kind of data for the boolean complement is friend only bitwise complement, friend, is only boolean kind of data. Okay, let's see it's also.